All right, let's jump right in. Today we're talking about a piece of tech that's quietly building the foundation for the next huge leap in AI. It's called the Agent-to-Agent protocol, or A2A for short. And its whole purpose? To be the universal language that finally lets all these different AI agents actually talk to each other and get stuff done.
And yeah, that question right there, that's the whole ballgame. We're seeing an absolute explosion of specialized AI agents. You've got agents that can book your flights, agents that crunch financial data, agents that handle customer service. They're all geniuses in their own little bubble, but making them work together, that's been a massive, massive headache. And this headache, well, it has a name, the AI scaling nightmare. It's the chaotic mess that happens when you try to connect all of these brilliant but totally isolated AIs into a system that actually works. And trust me, it gets messy, and it gets messy fast.
So here's why it's a nightmare in tech terms. The complexity, it just blows up. If you have two agents, you need one connection. Simple. But add a third, and suddenly you need three connections. A fourth agent? Now you need six. You see where this is going? You end up buried under this mountain of custom-built, super fragile glue code that breaks anytime a single agent gets an update. Your innovation just grinds to a halt.
Okay, so here's our game plan. We're going to start by really digging into that scaling problem. Then we'll introduce A2A as the hero of the story. We'll look under the hood to see how it works, how it plays nice with other protocols, and even peek into the future of how these systems are built. And finally, we'll wrap up with why this whole thing is such a big deal for, well, everyone.
You know, another way to think about it is that we've been building a world of digital islands. On each island, you have this brilliant specialist, but there are no bridges connecting them. So they can't team up to solve bigger, more interesting problems. That's the exact barrier A2A was built to smash right through.
And this is where our solution comes into play. Just think of the A2A protocol as a universal passport for AI. It's a standard set of rules that lets any agent, I don't care who built it or what tech it's running on, communicate and collaborate with any other agent. It's like Esperanto, but for AI.
So to get a little more formal, the Agent-to-Agent protocol is an open standard. And that part is absolutely key. This isn't some company's private product. It's hosted by the Linux Foundation and was created with a ton of input. We're talking over 50 industry partners. So it's a genuine community effort to build the core language for all these multi-agent systems.
So, how does this universal language actually work in practice? Well, A2A gives agents a very specific toolkit to make it all happen. Let's break down the most important parts. First up, and probably the most important tool in the box, is the agent card. The best way to think about this is like a digital business card. It's a public file that one agent can show to another and basically say, hey, here's who I am, here's what I'm great at, and here's how you can get in touch with me. And this business card has all the juicy details. It's got the agent's name, its address online, that's the endpoint URL, what kind of security it needs, any special tricks it can do, like real-time streaming, and, most importantly, a clear list of its skills. This is what makes it possible for agents to find each other automatically and know what they can do. Okay, so once two agents are talking, their whole project together is organized into what A2A calls a task. Now, a task isn't just a simple question and answer. This is so important. It's a stateful, ongoing conversation. Imagine a complex job like, hey, plan my entire trip to Tokyo. That whole process, with all the back and forth questions and updates, is managed as one single task.
And every single task follows a really clear life cycle. It starts as submitted, then it moves to working. It might hit pause at input required if it needs more info from the other agent. And finally, it wraps up as either completed, failed, or canceled. This whole structure is what allows agents to handle really complex, long-running jobs together.
Now, if you've been keeping an eye on AI protocols, you might be thinking, wait a minute, how does this A2A thing fit with that other standard, MCP, the Model Context Protocol? It's a super common question, and the answer is actually really simple. They're not rivals, they're partners. They were designed to work together. The key is seeing just how clear their jobs are. A2A is all about the dialogue between agents. Think of it like two colleagues negotiating a plan. MCP, on the other hand, is for an agent to use its own tools, like calling an API or pulling data from a database. So one is for conversation, the other is for action. And this auto repair shop example just illustrates it perfectly. See all the conversations? Customer to manager, manager to mechanic, mechanic to a parts supplier. Those are all A2A conversations. But when the mechanic agent actually needs to do work, like use its diagnostic scanner tool, that's when it uses MCP. They work together, hand in hand. So A2A gives us the universal language. That's awesome. But for these agent ecosystems to really truly scale, we also have to think about the architecture, the plumbing that connects them all. The easy way is just direct API calls, but there might be a better way. Which brings us to this big question. I mean, direct connections work, sure, but are they really the strongest, most resilient foundation you can build when you might have thousands of agents all trying to talk to each other in real time? Probably not.
And this is where something like Apache Kafka comes into the picture. Instead of agents calling each other directly, they just send messages to a central event hub. This totally decouples them. See, an API call is synchronous. You call, you wait for a response. A Kafka system is asynchronous. You just fire off a message and move on. This makes the whole system way more scalable, way more resilient, and it even gives you a shared history of everything that's happened.
So we've got the protocol, and we have a vision for a better architecture. But what's the actual payoff here? Why should we care about a standard communication language for AI? What does it mean in the real world?
For the developers building this stuff, the payoff is freedom. It's freedom from writing that endless, soul-crushing glue code. It means they can build AI agents like they're Lego blocks, specialized, modular, easy to snap together into something amazing. They can mix and match the best agent for any job, no matter who made it, and spend their brain power on cool new ideas, not just connecting wires.
And for businesses, well, all those developer benefits go straight to the bottom line. We're talking about unlocking way smarter, deeper automation, scaling up your AI plans without having to tear everything down and start over, getting new AI tools to market so much faster. And because it's an open standard, it lowers costs and keeps you from getting stuck with just one vendor. At the end of the day, A2A is on track to become absolutely essential infrastructure. You know how HTTP became the standard for the web? A2A is laying that same kind of foundation, but for a whole new era of collaborative AI. It's going to enable applications that are just so much more powerful than anything we could ever build with a bunch of siloed, lonely agents. And that leaves us with this final, really exciting question to think about. Now that our AI agents are finally learning to speak the same language, the barrier isn't can they work together anymore? The real question is, what incredible things should we have them do? The potential here is just staggering, and we're literally just at the beginning of figuring it all out.